Hello everyone, my name is Mansi Rajendra Kauri and I'm currently pursuing TY BTech and from MIT AOE. Now I'm currently studying with the subject of transport engineering and one of the unit is from that is bridges. Bridges are today we will be going to talk on bridges. What are bridges? How they are classified? What are the components, loads, IRC means what, and the failures in India. So, welcome to my today's presentation and get educated from this presentation. So let we will be speaking on classification, then components, loads, IRC specifications, and failures in India. And I have mentioned one of the case study for this. So let's go. This presentation covers the essential aspects of bridge for civil engineering students, focusing on classification, main components, load types, IRC, and notable bridge failures across India. Expect a detailed and technical walkthrough with practical examples and case studies relevant in Indian infrastructure. This is not only, as I have mentioned, good for civil engineer. It is I have been explaining it in a very simple manner so that anyone watching my video will be easy to understand. So here's I will go with the classification and types of bridges. Let's continue. So, classifications and types of bridges. First, based on structural forms. In that, I have mentioned the beam bridges, arch bridge, truss bridge, then suspension bridge, cable stay. Let's understand one by one. What is beam bridge? Beam bridge is the simplest load borne by beam means on I have mentioned the pictures in that you can see picture D says that it is a beam bridge where only you will find the poles and the bridge is attached to each other means column and the beam is attached to each other and the bridge is made. Second, a arch bridge usually we see in the from the ancient times, as picture A suggests that it's a arch bridge. What is a truss bridge is a triangular unit of longer span. As I have mentioned the as I have mentioned the picture, and in the downward side the steel form work which is done, it's come under the truss bridge, we can say it. So next is suspension bridge. What is suspension bridge? The you deck used from cables situated for very long suspensions. It is known as suspension bridge. Means the bridge which is connected with the cables which are as like work as a spring. It is known as a suspension bridge. Next is cable stud. Deck supported by a cable fixed to towers. It means that the cables as the suspension bridge and the cable bridge are most commonly seen at the very you at very rich cities where such as the Bandra Worli ceiling is also the one of the part example for that. So next let's move on based on materials. Bridge are types of bridge also are importantly made according to materials. So how materials and types get interconnected with each other, let's get known to that. Steel. First material we will be studying is steel. Steel means high strength, prone to corrosion. Steel has both the side. One is advantage, it's a high strength, and its disadvantage, it's prone to corrosion. So nowadays India infrastructure of bridge, steel has been less used. Basically, in previous times the truss bridge were made as much as possible because they would handle the load of the traffic and other things very well. So steel has been used at that time for making truss bridge. Nowadays it has been made, but not on a large scale, or not at a very like we can say at not very frequently, but it is made in some of the cases. Next is rcc means reinforcement concrete cement. So it's durable, common for moderate span. So as bridge we see on in our area, means in intercities, that bridge are most commonly made up of RCC. RCC bridge example is been given in figure number D, where it has been clearly shown that the RCC bridge is been built. Next is pre-stressed concrete. Pre-stressed concrete bridge means the bridge which is been firstly its part is been made in the local at the ground, and it's then attached to the attach it by as it's part by part, and it is been and then the bridge is being made in pre-stressed concrete. It's a cost effective for longer span, means the very large highways which connects to the two states, that highways are being made using pre-stressed concrete. Its example is given in the corner below the picture number D. It's a pre-stressed concrete bridge. Next is composite, combined material like steel and concrete. It's the figure number for figure numbers below C. It's the figure where the uh, where I mentioned the part it is stress. It is made of truss, so that bridge exactly gives the example of composite material. Composite material means where concrete also is used and steel is also used, and the truss and the beam part also been type of bridge in that the role is been played. So next move on the based on purpose. Bridge are also made according to a purpose. So let's understand with the purposes. So first is roadway bridge, railway bridge, pedestrian bridge. Let's understand with roadway bridge. Why we use, what is the purpose of roadway bridge? Roadway bridge purpose is to firstly reduce the traffic when two areas when not two areas, basically I can say when there are multiple roads on one in one area. So to reduce that heavy traffic, we make a bridge which can reduce the traffic, which will effectively distribute the traffic from that area, and the people will get timely to move and go smoothly to their workplaces. Next is railway bridge. Railway also has their bridge. So railway bridge, as you know, the as I mentioned the picture that is below C, figure number C, that it is a railway bridge. Basically, railway bridge is the bridge where the railway can run. It's very simple. Means when two mountains are there and it's difficult to connect the railway, so we have to build a railway bridge. And most probably, railway bridge are the example of truss. Truss and and their material is composite, combined material like steel and concrete. The railway bridge are exactly the example of that. Next come to pedestrian bridge. Pedestrian bridge is very rarely seen in India. Basically you can see it in the urban areas only. So next, let's move to the components of bridge. Types of components of bridge are substructure, superstructure, and I will be speaking on miscellaneous elements. There is not so come to the substructure. Components of bridge in substructure are abutments, support bridge ends, pioneer period, provide intermediate supports for longer span, and then foundation transfer load to the soil, open pile well. What does substructure see is that substructure is the part of bridge where the long span are been divided, and the superstructure comes says that deck form the road surface, girders or beam support deck load, slab create the flat deck surface, and bearing a controlled movement under loads. Substructure is the base part of the bridge, and superstructure is the upper part where the vehicle runs. Is the superstructure. So substructure is the minute parts which are been made and molded on the ground, and then superstructure is that the substructure where the molded parts made parts are being joined in the superstructure and the bridge is made. So this both plays the interrelation between them. And the miscellaneous elements are expansion joint accommodates thermal changes, parapets ensure safety of vehicles and pedestrians. Drainage pipes prevent water accumulation on deck. So, the miscellaneous we can say when the bridge is made, there should be a drainage, there should be the expansion of joint and accommodation should be well and smoothly, which is not been shown or which not harm the people while traveling. So the expansion of joint also may have the thermal changes. Parapets ensure safety of vehicles and pedestrians. Parapets means the lines which you usually see means like on the bridges where it helps us to reduce the speed on the road by the vehicles. So parapets are also very important on the roads. These are the components of bridge. Components of bridge are such a way and important for us. On that basis, the economical span concept is also very much important because economical span concept is important so that the bridge or the highway which are being made for our help is so important for economically for government and the taxpayer like the citizens of India. So economical span concept is also important. How? Let's understand that definition. The span length at which the cost per unit area of the bridge deck is minimum. Means the span is small, the cost is small. Simple. This is the calculation. But how the span influence the cost? Let's understand that. Shorter span need more pier, raise, substructure cost. Long span require heavier superstructure, increasing beam cost. Example, the RCC beam bridge. If the bridge is of RCC beam, as I have earlier talked in the types of bridges and their material. So if the bridge is made of RCC and it has beam structure, it of 12 its range is 15 to 25 meter. It has different cost because its material is different, and then its strength is different, then its length is different. So the span will also have the different where what is it different cost. Next come to truss bridge. If the bridge is made of truss, then 60 meter and above, its span influence and its cost is also then different. Next come to pre-stressed concrete bridge. Pre-stressed concrete bridge is of 25 to 45 meters. It's very long than all other above example, and it's also it has very high strength and more durable, more it has it has been its year of repair is also more means it's very best for all of the above when we compare it to them. So pre-stressed concrete bridge is I can say it's economically also good and for good strength good material it's the all above compared it's very good as I have said pre-stressed concrete bridge its example is given beside that image it's pre-stressed concrete bridge for 25 to 45 meter. This bridge is only made when the two states are being connected, not in a normal city and area it's made. But Struss Bridge, RCCBM, you can see in areas uh, means for traveling. This is the example. Span influence very much for the economic, but moreover to span than the material then means the whole cycle is been interrelated to each other. I can say that. Uh, as I have said, shorter span needs more material, needs more cost. The cost needs less material, but it has cost. As when I come to the large scale, the cost of the material becomes less. The span also increases. Then the economically the bridge becomes very well, so the taxpayer of the road the tolls that cost becomes less for the for the traveling person on that bridge. A flux, high flood level, and score depth. This is the terms the civil engineer before designing the bridge should need to keep in mind. And for a normal people, how it can be affected, that also we will be seeing from the same slide. Afflux. What is meant by afflux? Increase in upstream water level caused by obstruction like breach piers, computed using formulas such as Marin's. High flux can cause flood and erosion. So, how can flux? What is means by flux? When the breach is developed, the energy line or the water profile where from be, below the water, below the bridge, which has been made, which will be making, but in future, the below that the a flux is been designed. Means the bridge is designed according to a flux. After a flux, then comes to the high flood level. What is meant by high flood level? The water, sorry, the bridge below that, the pillars where the bridge is been situated, the level where the water ultimately must till that level was the flood high flood level, the water that can reach, not below the not above the bridge it should been come, as we see in the rainy season that water level increase and so the bridges are been over flooded. So this should not happen. This is known as high flood level. High flood level is the limit where the bridge and that level down, the high flood level is been uh, marked so that the water might reach till that, not above that. This is the design part. Score depth is that the it comes like score depth is when depth of the river bed ensured near bridge foundation during floods, classified by general, local, and contractor for the foundation safety. Score depth is the where the pillars where bridge is situated. Below that, the pillars at what depth the pillar uh, should be kept is that the score depth. Let's move to the loads on the bridge. Loads on the bridge. Loads on the bridge are of multiple types. The common loads are dead load, wind load, live load, seismic load. Then new loads are thermal force, braking and transition force, impact load. So let's go with the dead load. What is dead load? Permanent structural weight like decks, beams or footpath. Dead load means the load which is been dead load means which has been made, means the bridge itself is a dead load. The parts of bridge is been dead load means such that let's take one example. There is a bridge, then the surface of the bridge means we can say the where the vehicles travel, that surface is a dead load for the bridge. Then the soldiers of the bridge are also a dead load. Then the beam where the means the poles, we can say in general terms, where the bridge is been situated above that is a dead load. This is the example of dead load. Let's move to live load. What is live load? Variable loads from vehicles and pedestrian varying in the position and magnitude. Means the load which is not constant, which is continuously moving. The vehicles and the people moving on that is known as live load. What is wind load? Lateral force acting on deck and superstructures, means the wind coming and the structure holding it strongly is known as wind load. Seismic load. Force include due to earthquake affecting lateral and vertical stability. Means in future, whenever the tsunami, earthquake will be coming, the load which will be handling by the components of the bridge is known as seismic load. It can be vertically and laterally affecting. Thermal force, expansion and contracting stress caused by the temperature changes. Sometimes when the material is been differently used on the bridges, so that material will affect the temperature. The temperature will affect by the materials. Might it cause the changes in the stresses and contractions? Parking and transition force. force resulting from the vehicle acceleration or embarking action. Impact load. Impact load is additional dynamic force from moving vehicles influenced by span and surface roughness. So it's the normal. So this loads are as dead load and live load and wind load and impact load. These are most probably interconnected to each other. So let's move to the IRC load specification, means how this load are been designed and how this load are so important. Let's understand through the IRC. IRC. What is IRC? IRC, the Indian Road Congress. Uh, what IRC says for load specification, we seen before that what types of load, but types of load from where we have got it is got from IRC. IRC is the Indian Road Congress. So it says that IRC has multiple types. So IRC class A load, IRC class 70R load, class B load, load combination as design standards. So what class A says for regular road with cars, trucks and buses. It's a class A, means when we have to design the road for regular roads such as car, truck and buses, means intercity roads, we need to follow class A loading. When we have designed for heavy industrial or defense vehicles, then we have to follow IRC class 70R loading. But when we have to make for temporary beaches or pedestrian only, means where no more heavy live load will be included. So we have to follow class B load, and there are more. But I have mentioned the regular in general day-to-day life which we uses more roads. So next, load combination and their design is dead load plus live load plus impact load. We have earlierly studied water loads. So it's only the combination while designing the loads we keep in mind. Dead load plus seismic load plus wind load. Load factor. What is the load factor? Its load factor is a term means uh, a specific load which can be handled by the bridge. But when it comes to the extreme, how much it can go? So it's a load factor, safety factor we can say. So it's 1.5 to 2.5 as per the design state limit. Simple. Then design standard. Based on limit state method or consider ultimate load, fatigue and durability. Design standards are based on the types of road and then bridges. Example simple. Let's understand common bridge failures in India. Why bridges fails in India? Means what are the common reasons? Common reasons are such as structural failure, foundation failure, corrosion and maintenance, construction defects, and overload. I have taken this because it's the most important or most commonly where the bridges get failed. There are multiple and minor reasons also to make bridge fail, but the common are structural failure. How structural failure can fail the whole bridge or damage the whole bridge? First is the reason due to design flaws like underestimated loads or insufficient reinforcement. Example, Kolkata Mirzat bridge collapse in 2018 is the example of structural failure. Structural failure means the bridge the whole get damaged because of its structure, means before designing if the designer has been underestimated load or the people working on a site might be seeing wrong values, so it may affect the whole bridge structure. Next is foundation failure. Foundation failure means where the bridge has been situated, the columns below that or the beams below that, uh, if they are not capable of the bridge which been made above that for handling is the reason where the foundation gets failed. Foundation might get failed because of soil, because of dynamic different loads, so often caused by excessive score or shallow foundation such as failure at it's the example I have mentioned, Darbag bridge. Next come to corrosion and maintenance. Failure due to steel corrosion from poor drainage and neglect leading to delay, repairs and retrofittings. Corrosion and maintenance. This most probably been seen in the truss bridge, not rather than any other bridges, because the steel has been used in that. So corrosion and maintenance comes there more. But for because of that, bridge gets failed ultimately. If there is no proper maintenance for that, then construction defects and overloading. Poor workmanship and unauthorized heavy vehicles contribute significantly premature bridge failure. Yes, this also happens. When you observe bridge very closely, you might see that construction defects and overloading. Focusing on one of the case studies, as earlier I have mentioned, the case study named as Pune Chandni Chowk flyover collapse from 2024. It is not, we can say, collapse, but yeah, it had an incident. Slab collapse during the dismantling result in two fatalities and three injuries, causing major traffic disruption and Pune autocracy. Outcry. Outcry it is, public outcry. Causes inadequate demolition planning, absence of structural bracing, and lack of real time monitoring and traffic control in the work zone. Learnings: develop detailed demolition plans, ensure installation of temporary supports and safety roofs, conduct frequent inspection and safety audits during demolition. Why this happens? Because sometimes the project get delays from the government side or from the private, means the contractor side. If the project get delayed by 1 or 2 years, might the population from that area may increase. So it may affect in that way, or there is no good workmanship, no good design. There are multiple reasons we can blame. So uh, this cases happens, but in that cases we should not get hyper, or we should not blame any one person. Let's keep in mind it this way. Coming to conclusion of this video is important of proper classification and design. IRC code for safety, hydrological factors, maintenance and disaster preparedness. These all factors are very important for the design of bridge and the user side also. Both the consumer and the contractor and the government, we all are interrelatedly, like we can say, connected to each other for this bridges than the study we are doing. Thank you for listening my video, and this is all. I hope I have explained fair. I have tried to explain it's in a simple way, not used more technical words, so that the general public who is observing me can understand this video. Thank you from Mansi Rajendra Kaure.